Hi, everyone. Thank you for taking time to view my thesis presentation. My name is Aditya Venkatesh, and the title of my thesis is A Furniture Folding Methodology for Reconfigurable Aircraft Cabins. Before we dive in, I would like to go over a quick agenda of what's going to be presented to you today. We'll start off with the introduction, take a look at a little bit of literature survey, move on to establishing the furniture folding methodology itself, and then take a look at the two design concepts that were introduced based on the furniture folding methodology. And then we'll take a look at the illustration of these concepts within an airplane cabin. And finally, I'll wrap up by summarizing what was presented to you today. So let's start out. A passenger's onboard experience can be characterized as either comfortable or uncomfortable. A study suggests that passengers feel most comfortable during the takeoff and landing phase of an airplane's journey, and passengers feel least comfortable during the cruise phase of the journey. This is unfortunate because the cruise phase tends to make up the majority of the flight time. Another study suggests that the mere act of walking around a cabin improves passenger experience. A study suggests that passenger experience can be improved with careful attention to aircraft interior design and passenger flight experience. It would be ideal for passengers if they had the flexibility to pick and choose their onboard activities, but unfortunately, aircraft cabins are rigid environments that do not provide such flexibility. So how do we work around this? The objective of my thesis is to establish a general furniture folding methodology that increases the functionality of the furniture pieces within an aircraft cabin. Open on demand and reconfiguration are introduced as two furniture folding concepts based on the furniture folding methodology. The Bombardier Global 7500 will be the baseline aircraft for this purpose. The Bombardier Global 7500 has a unique four-zone configuration within its cabin interior. The club and conference section act as a more professional setting, while the entertainment and private section act as a more relaxed and leisure setting. So now let's take a quick look at some literature review. Space-saving and multifunctional systems are extremely advantageous applications on aircraft as space is limited within the cabin. A group of researchers in the Netherlands are working on a collapsible bed concept that reconfigures into an economy class 3-seat configuration. And this is illustrated on the left-hand side of the presentation slide. Seen on the right is AIM Altitude's Ultraflex concept that is aimed towards commercial aircraft. This concept provides passengers with a multifunctional space where they can choose to pursue any activities that they desire. We cannot talk about furniture folding without considering folding techniques themselves. Origami is a popular Japanese paper folding technique that transforms two-dimensional sheets into three-dimensional models. Over the years, researchers have worked on coming up with their unique origami designs and also refining existing models as well. Advancements in computing technology has enabled origami to expand into applications in medicine, architecture, space, and various other fields. The Yokohama port terminal is a prime example of this, as it has direct inspirations from origami. The next folding technique that I'd like to talk about is called foldabilization. Given a 3D object O representing a piece of furniture, the goal of foldabilization is to apply minimum amount of modification to O to allow its parts to be folded flatly upon itself or onto each other. This process methodically decomposes an existing piece of furniture and sequentially folds it in a specific direction to occupy less space. Seen on the presentation slide is an illustration of the systematic process of foldabilization. Finally, I'd like to talk about locking mechanisms and kinematic joints. As the term suggests, locking mechanisms allow parts to be secured in place. While there are different types of locking mechanisms such as warded locks, combination locks, and tumbler locks, this thesis will focus on the application of pin tumbler locks to keep rigid furniture components in place. We are all familiar with the purpose of kinematic joints. they allow motion in different degrees of freedom depending on the type of the kinematic joint. In this case, kinematic joints enable otherwise rigid furniture parts to be folded. And this thesis focuses on the operation of revolute and prismatic joints for its folding applications. Now that we've taken a look at a quick literature review, let us move on to establishing the general folding methodology. And that starts out by defining the design space. And the first aspect of that is identifying the function requirements and design parameters of the individual furniture pieces that are commonly found within a Bombardier Global 7500. In lay terms, function requirements describe what a product is used for, while design parameters describe how does the product do it. As I previously mentioned, a vector of function requirements and design parameters were identified for each individual furniture piece within Bombardier Global 7500. This information helps us distinguish the furniture pieces with dissimilar function requirements, and then we can expand their functionalities with the applications of the furniture folding methodology. All of those function requirements and design parameters were compiled into a MATLAB app for better visualization. This app provides the user with a list of function requirements and design parameters of furniture pieces found within specific sections of the Global 7500. The user has the option of toggling between the sections by clicking on the adjacent section button within the app as well. The next aspect of the design space is the design matrix. The design matrix characterizes the function requirements and design parameters of a furniture piece. And in this case, the design matrix is called the folding design matrix. Ideally, the folding design matrix would be a diagonal matrix, which means one design parameter influences one function requirement. In a not so ideal case, the folding design matrix can also be a triangular matrix where multiple design parameters influence one function requirement. But in such a case, there is a hierarchical process in which one design parameter needs to be altered to move on to the next design parameter to influence the function requirement. The folding design matrix is driven by the user's choice of the initial and final forms of the furniture piece. The next step in defining the design space is the modular breakdown. Modules are the decomposed segments that a user can modify to transform a furniture piece to their liking. Based on their modular composition and their function requirements, the furniture pieces within a Bombardier Global 7500 can be categorized into a comfort family or a function family. The seat, sofa, and bed fall into the comfort family, while the table, credenza, and cabinet fall into the function family. Also seen on this presentation slide is the modular breakdown into panels and columns of the furniture pieces found on Bombardier's Global 7500. These panels and columns are the pieces that are modified to transform the furniture pieces from Form 1 to Form 2. There are two different types of modules, common modules and singular modules. The furniture pieces that have overlapping function requirements and require no changes to their design parameters to satisfy the user needs are called common modules, whereas the furniture pieces that do not have overlapping function requirements but can have their design parameters modified to satisfy the user's requirements are called singular modules. But how do we quantify the change in the singular modules? This is done by studying the quotients of the singular module's initial and final aspect ratio, and this is termed as the folding module ratio. If the folding module ratio is greater than 1, it signifies a contraction. The folding module ratio is less than 1, it signifies an expansion, while a folding module ratio equal to 1 signifies the footprint of the module has not changed. Finally, let's talk about folding lines, joints, and locks. Modules are rigid pieces, and folding lines enable the modules to be modified in a manner dictated by the type of joint that is available along that folding line. In this case, there are two types of joints that we will be considering: sliding joints and rotational joints. These two types of joints can function individually or work in tandem along the folding lines to provide motion. Finally, locking mechanisms will be used to harness the furniture pieces in place, with locks being applied along every folding line to secure its respective joints. Each locking mechanism will contain at least 2 pin tumbler locks to account for redundancies. Now that we have all of that set up, let us establish the general folding theory. The folding methodology outlines a process to shift the geometry of a furniture piece into a new configuration while maintaining the piece's original material volume. This is done by identifying the initial and final form of the furniture piece, and then categorizing the function requirements and design parameters of those furniture pieces, and prioritizing those requirements based on the user's need. We will then have to identify the modules, folding lines, locks, and type of joints required for that transformation. And finally, we fold the furniture piece, thereby transforming the folding design matrix from Form 1 to Form 2. This provides the user with a new form of the furniture piece, thereby increasing the functionality of the furniture piece. One point to note is that this methodology considers furniture pieces with zero thickness for simplicity and to establish a proof of concept. Now that we have talked about the methodology, how do we quantify the change in the furniture piece's transformation? First, we do that by analyzing the change in occupied space. This system is in equilibrium, which means the furniture piece's initial volume is equal to its final volume, as seen in the equation on the presentation slide. The variables x, y, and z act as proportionality constants and signify the expansion or contraction process of the furniture piece in a specific dimension. The variables x, y, and z are also known as directional multipliers, and a directional multiplier value less than 1 indicates an increase in the respective measurement, while a directional multiplier value greater than 1 indicates a decrease in the respective measurement. Next, we can also study the furniture piece's change in compactness by comparing the initial and final values of the surface area to volume ratio, and this is termed as a total compactness ratio. The TCR value is inversely proportional to the compactness of a furniture, as it has a unit dimension of 1 over L. A larger TCR value for Form 2 when compared to Form 1 signifies a more compact Form 2, and vice versa. Now that we've established the general folding methodology, let us talk about the two folding design concepts that were introduced based on it. Open on demand is a concept that will offer passengers a multifunctional open space within an aircraft cabin. This method allows passengers to stow away furniture pieces when they're not in use, which opens up cabin floor space to a variety of onboard activities. Here is an example of a seat frame being stowed away, followed by an example of a sofa frame being stowed away. Here is an example of a bed frame being stowed away. One point to note is the direction of folding. The direction of folding considers the interior layout of the Global 7500, the placements of the bulkheads, the placements of the individual furniture pieces as well. The pieces are folded in a direction that considers the most open floor space once the furniture pieces are stowed away. Here is a quick illustration of the credenza frame being stowed away, followed by an illustration of the cabinet frame stowed away. Next, let's talk about the reconfiguration concept. This concept lets the user take advantage of the different modules of the initial piece and shift those modules into a new arrangement, thereby increasing the functionality of the furniture piece. This process is even useful when furniture pieces share common modules, as it allows the user to alter the amount of space occupied by a furniture piece. One point to note is the furniture pieces in the function family are not viable candidates for this concept due to their larger modular size and unfavorable modular orientation. Here is a quick illustration of a seat being reconfigured into a table, a bed being reconfigured into a sofa, and finally a sofa being reconfigured into a seat. This section focuses on the visualization of the two concepts within the cabin of a Bombardier Global 7500. Seen on the left is a partially sectioned top view of the furniture pieces in their extended form. Seen on the right is the portside partial section view of a Bombardier Global 7500 cabin's entertainment and private sections. Illustrated on this slide is the stowed furniture pieces on the port side, on the starboard side of the cabin. The part of the cabin floor highlighted in yellow is the original floor space that was occupied by the individual furniture pieces in their extended form. As it can be seen in this illustration, the stowed away furniture pieces open up a lot more room for the user to take advantage of. Seen on this presentation slide is the illustration of the reconfiguration concept within the Global 7500 cabin. Seen in this slide is a sofa being reconfigured into a seat, a bed being reconfigured into a sofa, and successively being reconfigured into a seat. Similar to the previous slide, the yellow part on the floor highlights the space occupied by the furniture piece in its original form. Now that we've visually analyzed these two concepts, let us quantitatively try to analyze the advantages provided by these two design concepts. Let us consider a zero-thickness seat frame with measurements similar to a lounge seat found on a Bombardier Global 7500. Seen on the left is the seat with seat frame with zero thickness in its extended form, and seen on the right is a seat with zero thickness in its stowed form. In the extended form, the seat has a length of 27.25 inches, while in the stowed form, it has a length of 2 inches. So let us start out by analyzing the change in occupied space in the length dimension. The directional multiplier value of x implies the seat has contracted by a factor of 0.74 in the length dimension. This is a significant contraction, thereby opening up a lot more of cabin space for the user to take advantage of. Likewise, we can also analyze the lounge seat's change in its compactness by studying its TCR values in its extended and stowed form. In its extended form, it has a TCR value of 0.71 feet to the power -1, and in its stowed form, it has a TCR value of 9.65 feet to the power of -1. The higher TCR value of the stowed form signifies a more compact seat. Finally, let's take a look at how we would implement these folding concepts. The realization of these two proposed folding concepts require the use of an actuation method to fold and transform the furniture pieces, and this actuation system can either be manual or automated. The manual actuation system is human-driven, and it is intrusive and a hands-on process, while an automatic actuation system is electrically driven, non-intrusive process or in hands-off process. But the automatic actuation system is a more complex system, which leads to its lesser reliability. At the same time, it has more equipment and requires more frequent maintenance while having a higher operating cost. Finally, let me summarize what I have just presented in the last 20 minutes or so. A furniture folding methodology that systematically decomposes the design space and quantitatively analyzes the transformation of furniture pieces from their initial form to their final form was established through my research. Two design concepts called open on demand and reconfiguration were introduced based on the folding methodology. These concepts allow a passenger to customize their travel experience by modifying the otherwise rigid cabin environment to their liking. While the proposed furniture folding methodology is aimed at furniture pieces within a business jet, it has the versatility to be adapted to any furniture piece positioned in any environment. Finally, let me talk about the future work regarding this research. The next steps would involve considering the furniture pieces with their actual thickness in full scale for the two folding design concepts. The successive step would be prototyping those furniture pieces while incorporating certification standards into the design and simulation process to produce airworthy prototypes. This step would also include human factor studies to understand the ideal implementation of these concepts from a user design perspective. Finally, here's a list of references of the material that was used in my presentation. Thank you for your time, and I look forward to addressing any questions that you may have during our Q&A session. Have a nice day.